All right, in this video I'll be doing I'll continue working on the Unit 1 review for Algebra 1. And so on number 8 here, it looks like we're going to want to distribute first so we can get rid of those parentheses. Again, that's part of simplifying. And so we distribute here 1/4 times t is 1/4 t. And then we got to multiply 1/4 times 9. So just as a reminder, I'll do that off to the side here. When I multiply 1/4 times 9, I'm going to want to write 9 as 9 over 1, and we multiply across, and so here we're going to get plus 9/4, and on the other side we have 12. So at this point, this is really what I was referring to earlier as a two-step equation. I'm going to need to subtract 9/4 on both sides, and then I'll be able to multiply by 4 to get rid of that 1/4 there. So it's going to take me two steps where we're using the inverse operation here. So let's go ahead and subtract 9/4 from both sides. So we get to do a little more fraction work here. We've got 12 minus 9/4. I'm going to write that as 12 over 1. And we know when we add or subtract fractions, we need a common denominator. So what we do is we multiply that bottom 1 by a 4, because I need a 4, which means I got to do the same thing to the numerator. And so when we do that, we get 48/4 minus 9/4, and you're going to get 39/4. And so we're going to get 1/4 t on the left is equal to 39/4. And so at this point, you could think, we really could write this left side as t over 4. Division by 4 is the same as multiplying by 1/4. And so at that point we would multiply both sides by 4. The other way to think of this is we're multiplying by the reciprocal. The nice thing about reciprocals is when you multiply them, you always end up with 1. And so the reciprocal of 1/4 is 4. So I'm going to multiply each side by 4. And notice here 4 times 4, or 4 times 1 over 4 times 1. We're going to get 4 over 4, or 1t, just t. And on the other side, notice those 4's cancel, and we're left with 39. And so our answer here is t equals 39. So again, we're going to sometimes have to put these answers in and use, like on a multiple choice test or standardized test, we'll have to enter our answer into some kind of box. And so here we would write 39 and fill out the 3 and the 9. And it actually doesn't matter if I put that 39 over to the left one, or I can move it wherever to the right. As long as I put the 3 and the 9 next to each other, the machine will read it just fine. All right, let's look at number 9. Now the first thing I want you to notice here is it just says simplify. We're not solving an equation here. All we're doing is simplifying. And so the first thing we're going to want to do is some distributing. Whoops, oh, I forgot I was going to do something for you guys. Before I do that, I better do some erasing here. So let me erase this. Now the way I did problem number 8 requires you to be pretty comfortable working with fractions. And so there is another way that a lot of people will teach you, and it's where you clear fractions. So I'm going to start right here, basically at this step here, and I'm going to show you how to clear fractions. So notice we only have one denominator, it's 4, and so the least common denominator for 4 and 4 would just be 4. And so we find the LCD of our denominators. Since there's only one, it's just that. And we're going to multiply both sides of the equation by 4. Oops, and you know what? I don't want to do that yet. So basically what you would be doing is this. Now when you do that, you end up distributing that 4. So instead of writing it that way, I like to do it just a little bit different. The thing is, I'm going to multiply all of my terms by 4. Like I was just showing you where you had to distribute the 4 here. Each term gets multiplied by 4 on both sides. So let's go ahead and do that. And so 4 times a fourth, again, those are reciprocals, you just get t. And then notice these 4's cancel, and you get plus 9. And on the other side, you get 48. And so this is kind of a slick way to avoid having to do all of this fraction arithmetic that we were doing over here. In fact, we could have even done it from the very first step. All right, so, and by the way, at this point, you would just subtract 9 and you would get the same answer. So either of these are perfectly fine. The second method I just showed you is a little bit slicker, I would say. All right, so now we're ready to work on number 9. So we've got some simplifying to do. We're going to have to distribute here. We get 2 times negative 6x is negative 12x, and 2 times negative 4 is negative 8, so we'll write minus 8. And then notice we have minus and then parentheses. We're going to end up distributing a negative 1 there. So negative 1 times a negative 1x gives you a positive 1x, or just plus x. And negative 1 times 7 is going to give you a negative 7, and we'll write that as minus 7. And then we'll bring down the 12. Notice we're not distributing times the 12 because it's not inside the parentheses. Okay, so notice the parentheses are gone, but we do have some like terms to take care of. Let's go ahead and combine our x terms. Notice this is a 1 and a negative 12, which is negative 11x. And I'm going to just bring down those other 3 numbers. And now we can combine those. And you may have done that in one step. So negative 8 minus 7, well, that's negative 15. Basically adding negative 8 and negative 7. And negative 15 plus 12 is negative 3. And so we're going to end up with negative 11x minus 3. So instead of writing negative or plus negative 3, we just write minus 3. And so negative 11x minus 3 is our answer here. So again, sometimes students get to this point and they got caught up in equation solving mode, and so they want to keep going. But in fact, we're done here. So remember, we're just simplifying. There's no equation to solve here. All right, let's move on. Okay, so on number 10 it says, in which step below does a mistake first appear in simplifying the expression? Well, let's see. In step 1, it looks like they distributed here to get the 12 in, and 4 times negative 2 to get the minus 8. They distributed negative 5 in the so actually that was it. And then to go from step 2 to step 3, now they're distributing again. Negative 5 times 2 is negative 10n, and negative 5 times 9, well, that's negative 45. And so notice they have the sign wrong here. It should be minus 45. So there's the first step where we have a mistake, but that's not the only one. Notice 2 times 8n, when we distribute here, we get 16n, and 2 times 6, they forgot to multiply the 6 by 2, you get 12 there. And that's actually a common mistake, to forget to multiply times the second term in the parentheses. And so here, we're ready to go with our explanation here. The first mistake occurs in step 3, and basically the 45 has the wrong sign, and the 6 should be a 12. All right, let's move on to number 11. It says solve the literal equation for h using inverse operations. So basically now we're going to take our equation solving skills and we're going to use them to solve this equation for h. Notice it's currently solved for a, but we don't want it to be solved for a. We want it to be solved for h. So, you know, previously we were solving equations and we were getting a number, like x equals negative 5/2. And that was the solution to the equation, the one and only solution. If you went and plugged it back into the original equation, it would make the equation true. That's not what we mean here when we say solve. We're really rearranging the equation so that instead of being solved for a, it's solved for h. And so now one of the things we haven't talked about in this video and doing all these problems so far, well, I guess we did do one problem with fractions, but Normally with fractions, you want to get rid of those up front. You know, the sooner you can get rid of fractions, the better off you'll be, right? So you've got 1/2 BH here. How could we get rid of the 1/2 BH? Well, just like we did earlier, remember we had 1/4 x and we multiplied by 4. Here we could multiply by 2 on both sides of the equation, because we know whatever we do to one side we have to do to the other. And so that's what we're going to do. We're going to multiply each side by 2. And on the left, I know when you multiply reciprocals, you get 1. So we're going to get 1BH, or just BH. And on the other side, we're going to have 2A. Now I'm going to put the 2 in front of the A. We normally put the number first. And so now we're one step away from getting H by itself. Remember, H is what we're wanting to solve for. So we need to get rid of that B, and it's B times H. So the opposite of multiplying by B is dividing by B. We're doing the inverse operation. Notice these B's are going to cancel, and you're left with H is equal to 2A over B. And so that's our answer here. So it was originally solved for A, now the equation is solved for H. All right, let's move on to the next problem. Okay, so this is a similar problem. It says solve the literal equation for y by using inverse operations. So basically, sometimes I like to circle the letter that I'm trying to get all by itself. Notice that in order to get y all by itself, well, for one, I'm going to have to divide by b. And the other thing I'm going to have to do, I need to get rid of this ax term. I would have to subtract ax from both sides to get rid of that term. Now the question is, what do I do first? Well, this is like solving a two-step equation. We always add or subtract first. And in fact, what we want to do, I'm going to go ahead and get rid of this y here, or this circle. So I'm trying to, I want to leave alone the by term and get rid of that ax term. And so we're going to want to subtract ax on both sides, which you could also think of it as you're adding negative ax to both sides. In any case, on the left, these guys add up to 0, and you're left with just by. And on the other side, you have c minus ax. Now you might be tempted to somehow combine these, but you can only combine terms that have the same variables, and these don't. And so these are not like terms. Nothing we can do with these to combine them. But notice we're one step away. Remember, we're trying to get y all by itself. We need to get rid of that b now. Since it's b times y, we'll do the opposite and divide. And so we get y is equal to c minus ax all over b. And it doesn't look the nicest. It's not a nice number, that's for sure. But that's our answer. That's the best we can do. We've isolated y on one side. The equation was originally solved for c. Now it's solved for y. Now, I'm going to write the answer this way, but there's a couple of other ways you could have written it, depending on what you remember from your previous algebra experiences. You could break the fraction into two parts and have c over b minus ax over b. Or the other way you might have written it is as minus ax plus c over b. Really, these are just in the opposite order. And any of these answers would be fine. All right, let's look at number 13. All right, well, this is what we call a proportion. And it's when you have a fraction equal a fraction. And so one thing we learned that's a real nice handy-dandy fact about proportions is you can cross, or I should say the cross products are equal. 6 times y plus 14, 6 times y plus 14 is going to equal 7 times y. All right, so now we can solve this equation. Notice we have some simplifying to do. We're going to distribute on the left. We'll get 6 times y is 6y, and 6 times 14 is 84. And on the other side, we just have 7y. Now, we've simplified everything that we could. And so now the next step is Do we need to isolate y on one side? Is it on both sides? It sure is. Now, normally I would try to keep my y on the left, but because there's a single term here, I really don't want to subtract 7y. You could do it. You would have 0 there, but it turns out to be easier to subtract 6y on both sides. And so that's what I'm going to do. So we end up with 84 is equal to y, and we are done. Let's move on to number 14. Actually, you know what? This will be a good place to stop. All right, so we'll have one more video.